Okay, folks, here we go, starting with a little bit more of an in-depth idea into this idea of exponents and how they affect a graph. You did your notes yesterday and you saw some ways to graph these with a table, which always works for you. The issue with the table is sometimes it doesn't give you the entire graph. So we want to look at a way where we can see the most important features of a graph and give an accurate sketch of what that graph looks like. And what I want to do is relate this back to the idea of vertex form when we talk about parabolas and square root functions and even the linear functions we saw yesterday. If you notice on your screen, we have this parent function, or this general form, this vertex form, so to speak, of an exponential function. And as we have this, you see some of our old friends showing up here. We have a, that shows up as before, and that behaves very similarly. We have h and k, that shows up in the order pair, and that behaves very similarly as well. What we have to remember when we deal with exponential functions, a couple other things is a does some stuff. It's a stretch and a compress. It's also a reflection still, just like before, so we have that kind of reflection piece right there. But it's also this growth and decay factor as well. And that's pretty important as we look at this because we have to figure out exactly what that's going to be in terms of our graph, what that looks like. And growth and decay have very different characteristics to them. If you remember from your notes yesterday, they talked about what made growth and decay, and we talked about growth. We know that's going to be when b is greater than 1. Okay, that's important. B is greater than 1. When we talked about decay, that's going to be when b is greater than 0, but less than 1. Notice that b is never equal to those two values. B will never be equal to 0, nor will it be equal to 1. If that was the case, you'd have a flat line, and that's not what we're dealing with, growth and decay. And as we have a growth function, as we know what that looks like, that's going to grow kind of on a curve. That's how we start things, and that might change depending on some of the other stuff, but that's where we start. And decay starts like this. And so that's kind of the parent functions in the look of what they are. It's a growth up and to the right or a decay down to the right. So that's what we need to make sure we talk about as we go. But some of the things we see in there are very similar, especially with the h and k. That's what we're going to kind of begin with. And I want to show you a couple things here, especially on decimals and how those work together and what happens in that. So you see on your screen we have this graph. Here's my parent function up here. As you see, that tells you kind of what we're dealing with. We have some sliders here and put in some specific values into this. And I'm going to change these here. We're going to start with an a value of 1, a b value of 2, h and k are at 0. And so h and k, if we look back at what we just said, h and k, this was our starting location. Okay? And that's going to be very important to us as we go because the starting location is going to help us graph our function very quickly and effectively. So as we look at what we have, we know h and k are 0. So that means our origin is our starting location. And as you see the shape of this graph, what it looks like, it's growth because b is bigger than 1. But this graph goes up and to the right, and you'll notice as I kind of zoom in on this, notice how it gets really, really, really close to this line y equals 0, but not quite touching it. Okay, if I was to go along this, you notice I'm not quite at 0 on that y value. I'm really, really close, and eventually we get there, but it doesn't actually touch it. We call that our asymptote. Okay, and so if we go back to here and we talk about that, we want to look at this asymptote, and I haven't seen it yet. That is the equation y equals k. That's very important to us as well. That's going to help us get some stuff out of the way and graph what we have. But the two keys that we want to start with when we graph a function is those idea, the asymptote and that starting point. So we have a starting point of 0, 0, and we know my intercept, or my asymptote, excuse me, is the line y equals 0 as well. A couple things you notice about the values we see of a and b. That's going to help us graph the rest of this thing. If you notice a, okay, a is the value, and I'm going to put this on the y-intercept, and notice what the y-intercept is. Now, if I change b and I start putting this in motion, notice what doesn't change. Okay, that's pretty quick, so let me slow that down a little bit. Okay, notice how that y-intercept, that value is not changing. Notice what the value of A is, and notice what that is. Okay, so changing B does not change that value at all. We know my asymptote is y equals 0. So if you notice, the distance from my asymptote to this y-intercept is 1. All right, well, let's stop this here, bring B back to 2 where we started. And let's start changing A and watch what happens there. So as we change A, that moves. Notice what that does. Now all of a sudden, that y-intercept is starting to change. If I stop it anywhere, notice what matches up. A is negative 4.04. So is that y-intercept, or that distance from my asymptote. We keep going. Again, my asymptote is y equals 0. Stop it again, 4.335. The distance is 4.335. So this value of A is very important to us. That tells us what our distance from the asymptote to that point will be. So let's go back there and kind of add this as well. So A is also, when we talk about this starting distance here, okay, that's important. That's a starting distance from your asymptote. Okay, the asymptote is really helpful to us to help graph this stuff. All right. The other piece we're going to look at now as we go back to decimals is just another point that helps us graph something nice. So let's get A back to 1 here, where it was before, all things back and considered. Okay. And let's extend B up a little bit. Let's make B, I don't know, let's make B 5. Okay. Let's make B 5. That'll help us a little bit as we move. Now, as we look at these things, if I go find the next nice point from my origin, remember, it's a starting point, it's your origin is. That's what H and K are, it's a starting point. If I go here, 0, I haven't moved left, right, I go up 1. That's what A is, that helps me there. The next one, if I go over to the right 1, and then I go up, I get to this ordered pair 1 and 5. Okay, if I get there, 1 and 5. Now, if you look at what I have there, you see B is 5, and you might say, hey, that's going to go over 1 and up 5. Well, as I start changing things, let's change A to 2 now. Okay, so instead of over 1 and up 5, that doesn't get me to the graph. But if I keep going to this point, I get to 110. So if we notice what I can combine here to get me that, I have a value, and A is 2 and B is 5. So that's going to give me that 10. All right, so that's kind of a distance over 1, and we go up 10. So it's basically the product of A and B. So as we move, we're going to use A and B to get to that next point, and that will just help me shape the graph a little bit. All right, so that's kind of our information as we have. Now, if you notice what H and K does, that new starting point. All right, I'm going to put these little lines in here so we can see them a little better. But if I take H and K, let me get this back to 2 and 1, kind of our parent function we start looking at stuff with. 2 and 1. Got it. If I start messing with H and K, I'm going to make H a little bigger. Okay, H would be 4. Let's make K, I don't know, negative 2. Okay. Notice how that graph is shifted. Okay, that point that I had has now shifted. I've gone here from 0, 0. I'm at 4, negative 2. That's, again, that starting value, 4, negative 2. Okay. If I go up here, notice I go from 4, negative 2 to 4, negative 1. That distance we talked about with A is 1. So go up 1 from that point. That's that nice kind of new almost intercept, so to speak. Notice my horizontal asymptote is y equals k, so that's y equals negative 2. And if we think about that way of moving with B and A, B and A is 2 and 1, so if I multiply 2 and 1 together, if I go right 1, I should go up 2, and I'll be on my graph, and I am. So all those things help us graph that as we go. It's just a matter of shifting and stretching and compressing, just like we did with square root functions and just like we did with quadratic functions. Different pieces play different roles. So let's jump into a couple examples and see exactly how those things work together. So let's go here and we'll start with this one. So take a second, get this down in your notes, and we're going to graph this one without using a table at all. You can always use a table, but again, sometimes your table doesn't give you all the values you need, and if we go about it this way, we will always have the shape that we want. So let's start, first of all, by identifying what H and K are, what our new center is. So we want to find H and K. That's that. And just like before, That is the values that show up as addition and subtraction. And just like before, with the x value is the opposite of what you see. So instead of 5, it's going to be -5, and we'll have a -4. So that's kind of our new starting space, all right? And I'm going to go there, and we're going to put a little kind of like plus sign there just to give us a place to go. So I'm going to go left 5, 1, 2, 3, 4, 5, down 4. I'm going to put a little, kind of like a little plus there. That's going to help us get oriented. That's our starting point we want to start at. Okay, so first and foremost, we plotted our starting point. Next, we want to find our asymptote. Okay, and we said the asymptote was y equals k, which in this case is -4. So y equals -4. So we're going to go and get a dashed line. This we actually do need to plot. We have to plot that as a dashed line. And the nice thing is it goes right through that starting point. So there's my asymptote right there. Okay, I've got that. That's that line I'm going to get really, really close to, but never touch. Okay, a couple other things we need to talk about. This, the idea of B. Okay, A is 2, B is 3. That means my graph is going to look like this. It's going to go up and to the right. All right, it's a growth function. All right, so with A being 2, okay, that's going to keep it going up and to the right. It doesn't reflect. So I know my final graph is going to look like that. That's a good thing for us. So this is the shape we want to have in our graph. Okay, so let's plot some things. We said A. A was that distance up from my starting point. So since A is 2, I'm going to go to my starting point and go up 2. 1, 2, I'm going to put a point from that starting point. So again, there was my starting value. This guy was my starting value. A was 2, so I went up 2 from that point. Okay. All right, well, that's a good part. Now I have to figure out how I move again to find my next nice point. Well, all we're going to do is take A and B and combine them together, and that's going to give me 6. So that means I'm going to go right 1 and up 6, okay, from the blue. So if I do that, I go right 1, up 6. There's 4, 5, 6, and that will be a new point for me right there. So I'm going to get rid of those little dots. I don't need those in my final graph. Okay. So from there, I know now I have all the information I need to be able to graph this. I know what the shape of my graph looks like. I know how it's going to change stuff and how it's going to move left to right, and this will help me graph my line. So as I do that, I come up here, and I just come down, and I kind of pass through here, and then keep going real close to that line and level off. And that's going to be what my graph looks like. Okay, so we didn't do a lot of steps. It's just a matter of understanding how this all works. And we started off by figuring out H and K. That's important. That's that little starting guy right there. That's where we started. We then, so this is first part. Then we did the asymptote next. Y equals -4. That's that guy right there. Okay. The third piece was figuring out what my shape of my graph needs to look like. And then my fourth piece was this idea of how do I figure out my movement from that. Again, it's just multiplying A and B together and going from your starting point, going right 1 and up that amount. And that will help us kind of get where we need to go. All right, so that's a model of growth. Okay, it's not overly difficult. It's just a matter of getting your stuff in order. All right, so the next one, let's do a decay problem. All right, so let's go through and do the same steps in the process. Again, first and foremost, we're going to find H and K. Let's find HK. Well, there's +3 and +6. So that's going to be a -3 and a +6. That's my new starting point. So let's plot that right away. So left 3. So 1, 2, 3, up 1, 2, 3, 4, 5, 6. There's my kind of starting spot right there. It's not part of my graph, but it's a location that helps me graph. All right, so there's that one. Next one, we want to figure out our y and our asymptote, not our y-intercept, our asymptote. And y equals k, so y equals 6. Let's go grab my line here. So help me pick the right one. I got it. It goes right through that ordered that point there. I have it. Okay, so let's identify A and B next. A is 3, B is 1/2. So this is decay now. So that means my graph is going to start high and come low like this. And since A is positive, it's going to keep that shape. If A was negative, I'd just flip it. All right. So then we're going to plot our point. So A is 3. That means I go up 3 units from this guy. So go up 3, 1, 2, 3. There's my point. Okay. And then we can kind of go from there. Let's multiply these together. We get 3 over 2 when I multiply. Now, since this is decay, instead of going up, we go down. Okay? Instead of up, we go down. So here we're going to go right 1. We're going to go down 3 over 2. That's how we're doing. So it's from, I'm sorry, we're still going up 3 over 2. Excuse me, I made a mistake there. It should be up 3 over 2, not down 3 over 2. So I go right 1 and up 1.5, which is right there. Sorry about that mistake, guys. All right. So notice that the amount you're going up is not as much as it was before. I'm actually below that new point. So I take that, and I know my graph is going to go start high and come down through here, and it's going to look like that. That will give me my graph. All right. So dealing with that, it kind of helps us understand how we can graph these a little more efficiently, whether or not we have standard form or not. But all these idea of H and K come back into play again. An asymptote is a new term that we have in there. Remember, that's just that level line that we have that we're going to deal with. We know about growth and decay factor. 1/2 is my decay. In this case, because it's less than 1, I'm bigger than 1 here, so that means it's growth, and just what it looks like. So just take those things. A and B are important again. We multiply those together to know how much we move to the right and up all the time, and that will help us figure out what my graph looks like. So important things there. That should be enough information. You're just going to be graphing things today in your work. So use those skills. And as always, you have Desmos to check your work after you've done it yourself. So hope that clears things up. Hope it makes it easy, and we'll chat some more about it tomorrow. Have a good day.